Hello, everyone, and welcome back to the afternoon session. I'd like to welcome Paul Albert, who will be presenting as part of the ReCiter team that includes Sarbajit, Dutta, and Terrie Wheeler from Weil, Cornell Medicine. And Paul, take it away.
Can you hear me okay?
Yes, we're not seeing any slides yet.
Okay, yeah, I'll get to that. Sarbajit, if possible, is going to co-present as well. So if you want to bring him into the presenter circle. So for the second piece of it. So I'm going to share my screen. And I'm actually going to turn off my video. I've proven that I'm a non-silicon. So I'm going to turn off my video to improve performance. Okay. All right. Is this okay, Gwen?
I can see your screen. You're now in normal mode instead of presenter mode.
Okay.
Yes, now you're in presenter slide mode.
Perfect. Okay. So my name's Paul, and I work at Weil Cornell along with my colleagues, and today I'm going to talk about a system called ReCiter. So ReCiter is an open source author disambiguation system for academic medical institutions. And at our institution, we always start with the so-called business case. So what do people want out of a publications management system? And it's a variety of things. People want to know so external affairs, for example, wants to know which publications to promote. Department chairs and deans have similar, although not completely the same needs around reporting on publications. Deans have to decide things like decide who to recommend for awards or who deserves tenure, and if their institutional strategic vision is bearing fruit. And faculty want to be left alone. So before we proceed, there is a kind of question that the whole audience is thinking, and that is, why aren't you using ORCID? And in a longer version of this presentation, I could go through the reasons, but I'm going to show you two reasons. One of which is that there's a delay between when publications appear in, say, PubMed and when they appear in ORCID. So here's a case where there's a 7-month delay. And if you go back to the previous slide in the business case for external affairs, they want to know publications that came out within the last month or the last week. Another problem is that ORCID allows a large segment of users to essentially hide their profile from third parties that are using it. So that's a problem. So we asked ourselves, what does an effective publications management system look like? And this is our list. And the first thing is that it needs to be controlled by institutions. We shouldn't have to secure explicit permission for curating publication lists. It should allow librarians and departments to review the articles because they're really doing a lot of that work anyway. It should come as a series of suggestions, and the candidate articles should be scored on the basis of likelihood, and it should exclude a lot of unlikely possibilities. Fourth is that it needs to include publications from missing or prior affiliations. So 8% of Weil Cornell publications by active faculty lack a correct affiliation. So those are falling through the cracks. We need to run it daily for a large number of people, and then we need to share the data through a set of web services. So our system that tries to address that is called ReCiter. Here's how ReCiter works. We create a scholarly identity for a person. Then we use that identity to retrieve a set of candidate articles from PubMed and optionally Scopus. We use machine learning to estimate the likelihood a given scholar wrote each article. We collect feedback from librarians, especially, and department staff on the most likely articles a person has written. And then we share the data through a set of web services to downstream systems. So let's focus on this first step. The librarian is really the model for how ReCiter works. So we're trying to think of, we're starting by thinking, what kind of information does a librarian need to effectively disambiguate a scholar's publications? And it turns out that a lot of this information is maintained by institutions, affiliations, years of degree, grant numbers, name variants, departments, relationships, emails. So here's an example of someone who has all that data. And institutions have a ton of data about a person, and all this data can be leveraged to make intelligent suggestions regarding what this given scholar actually authored. We take that data and we make it into a JSON object. And then with that data, we retrieve a set of candidate articles from PubMed and optionally Scopus. So for example, let's say you have a relatively unique name. My name is relatively unique. You do the kind of typical PubMed search, and then you search for the emails on file. If somebody has a more common name, we go into, with ReCiter, we go into something called strict mode. So we're searching for the name as well as certain qualifiers that are available from that identity object that I showed you before. And then people who have multiple names on record or compound names, we search for both. ReCiter has a separate module that interfaces with PubMed. And this is what the output looks like. So the output is in JSON. Those of you who've had to get data from PubMed know that it typically comes in the form of XML, which is it's not as easy to use. We have a similar module for Scopus. So we use Scopus to retrieve additional data. Scopus is just optional. You don't have to use it with ReCiter, but it does provide time-cited data, which our users are interested in having. And sometimes it contains the verbose full name of a given author. With ReCiter, what we're trying to do is insulate developers from quirks in the source system. So PubMed has that XML, it throttles requests. It's problematic in a couple ways. Scopus sometimes includes duplicate authors, so we handle that problem. There's some nice touches. So we output a display date and a standardized sortable date appropriate for use in spreadsheets. We compute a single canonical publication type. We infer target author by using a set of heuristics, comparing the author names against in the article against the names in the identity. And then ReCiter also allows you to look up publications since the last time the system was run. In step 3, we're using machine learning to estimate the likelihood a given scholar wrote an article. We feel strongly that institutions shouldn't pay our busiest, most creative people to do busy work. And when you use machine learning, it actually becomes it becomes somewhat effortless in order to curate large numbers of publications. This is a lot to take in, but basically what we have here is a series of different types of evidence. And what we're doing is we're comparing data from the article to data from the institution. So as an example, if you look in that second line there are 2 people listed on this candidate article as being co-investigators with our target scholar. And these people also appear as co-authors on the article itself. So that immediately increases the likelihood that this article was written by our person in question. And there's a variety of other evidence as well, and it's all quite interesting, but I don't have time to go into it. So when we use a critical mass of identity information, authorship identity is actually rarely ambiguous. Only around 5% of the time is the likelihood a given person wrote an article between 10 and 90%. So what does this mean? It means that we don't have to show large numbers of publications to the curators of scholars' profiles. So we can just discard them and feel good about it because we've saved people time. All right, in step 4, what we're doing is we're collecting feedback from mostly librarians and sometimes department staff on the most likely articles. And I don't have time for a huge demo, so I'll just show you what the system looks like. So here's a profile for Yak and Buck. And articles are sorted into suggested, accepted, and rejected. So here are 2 suggested articles, and each article has an evidence score on a scale of 1 to 10. 10 means it's highly likely. And typically, I would hope Yak and Buck has better things to do than review his publications. So I don't want him to spend time curating his profile. I want to do it for him because I have all the evidence and I can do it really quickly. So if I'm confused, though, I can come in here and I can look at the evidence and review it and say, okay, there does seem to be a fair amount of evidence. And then for this one as well, I can do that, and then I can say, okay, accept all, and then click refresh. In step 5, we're using web services to expose the ReCiter system to downstream services. So this is an example of an API. So it's in ReCiter, it's called feature generator. We provide the person ID, whether we want to use a gold standard to help improve the scoring. And then there's a variety of other parameters. And then it outputs basically data about the article and then evidence data as well. So you can see that the target author output is in there as well. So a lot of people actually care about target author. All right, so we've discovered that there's a critical point in the quality of publication data where you can use it to confidently perform important tasks. One of them is that we've integrated our ReCiter with our public-facing profile system. So feedback from ReCiter gets updated in Vivo on a daily basis. I'm not going to go through all of these, but we collect a lot of really positive feedback from our users about how much they enjoy having publication data, about how they like having the data that gets updated so frequently. We circulate a report on a monthly basis called New Pubs, and we track 4,000 people, including residents. So these are publications written by any of those 4,000 people, and they go out to about 120 people on a monthly basis.
Paul, sorry, this is your 2-minute warning.
Okay. 2-minute warning, huh? We didn't start at 12:25?
Yes, we did.
Oh, okay. I'm not doing the math correctly. Okay. Yeah, so, sorry. Anyway, so we have a variety of different reports. This is the architectural diagram for ReCiter. I'm going to turn it over to Sarbajit at this point. Sarbajit, good luck with those remaining 2 minutes.
Sure. Hey, everybody. I'm just going to quickly go through. So we collect different identity data from different systems and aggregate it into the for ReCiter. And then ReCiter, the key design principle is microservices. So we have PubMed as a standalone component, Scopus is a standalone component, and then we have Publication Manager, which Paul just demoed, which is also a standalone component. So everything talks through each other via microservices or APIs. And we expose the data to downstream systems or reporting tools, such as whatever analytics you need on publications that Paul demoed, profile systems such as Vivo or departmental lab websites that you have in your organization. Next slide, please. So ReCiter, the idea of ReCiter was so that it can be installed very quickly and easily by anybody. So we came up with this CloudFormation templates, which essentially allow you to install ReCiter and get set up and running in Amazon Web Services within like 20 to 25 minutes. And this is also available through GitHub as well.
Sarbajit, let's go to the end because I'm a bad person and I didn't give you enough time. Can you give a sum up slide?
You can have a few extra minutes. We have a few padding minutes, so go ahead.
So we have a ReCiter Slack channel. So if anybody interested, please join and you can ask questions there. We're happy to answer them. And everything is open source and available to GitHub. The ReCiter core, the PubMed retrieval tool, the Scopus retrieval tool, the CloudFormation, the machine learning piece, and the ReCiter Connect, which is actually what being used to populate Vivo or profile system. Well,
Yeah, I apologize. I was off by 5 minutes. I was like, oh, I'm doing so good. Nope. All right, so that concludes our piece of it. Sorry I didn't give. Sarbajit is basically the kind of genius behind like all the work that you see here. So I want to give him a ton of credit for that. So we're very forthcoming with if anybody wants to reach out, wants to use ReCiter, we'll help you get up and running if you wish. So that's it.
Thank you so much, both of you. And there is a general Q&A at the end. If anyone has additional questions, I have noticed some Q&A. So please do continue to put your questions in there. And now I'd like to move to Dan Coughlin from Penn State Libraries to talk about researcher metadata.
Thank you. I'm trying to share my screen here. I did, arguably two of the most dangerous things you could do before a presentation, which was update it, as you're sort of getting ready to go, and I ate a salad for lunch. So let's hopefully the distance allows me to make sure there's no lettuce in between my teeth, so to speak. So good afternoon, everyone. I'm Dan Coughlin from Penn State University. Thanks for providing me with the opportunity to to speak this afternoon about Penn State's researcher metadata database. Thank you to Carmi, Greenwood, and Kim Lloyd for their assistance in the logistics for the presentation. Start off by saying that I don't love the name of this. Initially, my boss at the time referred to this project as a unicorn because it was something she wasn't sure would ever exist. She would kind of say, oh, it'd be great if we had this system that could, whatever, and then kind of refer to it as, a unicorn. And as we were progressed through it, I like unicorns. I'm a pro-unicorn person. My daughter just turned 6. She's obviously very pro-unicorn, but I wasn't sure if it would be taken seriously with that name. So we evolved to starting to refer to it as the researcher metadata database. I'll take suggestions if people have them on that, on a new name. But before I get too in-depth on it, I'm going to do a brief overview of some of the relevant systems that we have at Penn State towards this system. So we have several systems that have records of faculty activity or researcher information. We have some that are locally developed solutions, some that are vended products. Those are the locally developed solutions. We have ScholarSphere. It's our open data and open access repository. Obviously, the researcher metadata database. This is sort of our research information management system. And then we've heard about some of the vended products that the other folks have as well, or have been presented on. One is Pure, which is essentially our expert finding database. So I don't need to go into in depth on that because there's been another presentation on it. We also have Clarivate or Web of Science. So similarly to Pure, we get a set of publication or citation data for our researchers that we could access. Additionally, we've been able to link in grants and scholarships through this data as well. And next we have digital measures from Watermark. So this is another application of database of faculty reporting. So where Pure and Clarivate largely we're using for primarily publication information, digital measures is a system that has more information related to the faculty member than those other two databases specifically. So it has things like student reviews of courses, biographical information. Additionally, it's a system that faculty can control the data and verify it annually. So they put data into that system, and that data is then used to create an annual review document or a university dossier. We also have the the ability to update information that we're asking for from our faculty in this system. And it's part of their existing workflow for annual review, albeit maybe a bit begrudgingly. So those are just some of the more relevant systems we have. A little bit of history for us. A couple of years back, we had an open access task force that was charged by Penn State's provost, Nick Jones, and the dean at the time of the libraries, Barbara Dewey. In that task force, there were some mini teams or subcommittees that were created with different charges. And the subcommittee that I was on was responsible for coming up with an implementation plan for the open access policy that would hopefully get passed one day. One of the things that was continually repeated was to try to make this as automated as possible. Don't interrupt workflows, make this as simple as you can. If we're going to ask researchers to provide openly accessible copies of their work, then we need to make sure it isn't disruptive. So around that same time that we're thinking about how we're going to effectively implement the open access policy, we're working closely with the Office of the Vice President for Research as they're rolling out Pure. And they asked us because of our team's experience with Watermark's digital measures. So one of our team leads the effort to make sure digital measures is successful on campus. They understand, not only the digital measures system, but university data, various streams it's flowing into better than anyone I know at Penn State. So when we were asked to help out with rolling out Pure, it felt like good in terms of our ability to help and also our ability to learn about some of the other systems. So as we're helping out with Pure, a common question we would get from IT people at colleges and campuses or marketing people from those places was essentially, I'm simplifying it a bit, but should we be using the data in Pure or digital measures, right? In particular, to populate their unit's faculty web pages. This has had us a bit concerned about fractured efforts at the university and perhaps inconsistent data use. So some colleges using Pure to populate faculty profiles and others using digital measures. They both have these really rich data sets. People aren't sure which to use. So we had these two issues that kept coming up around that time. One, trying to figure out how to automate or simplify workflows around an open access policy that was being developed. And two, providing access to the data at digital measures. And so as discussions were going on, we noticed we needed access to the data in digital measures in Pure in order to automate or simplify the workflows around our open access policy. So we started creating this database, the researcher metadata database, that would be able to combine data elements from both of these sources, as well as additional others I won't get too in depth on in this presentation, but our electronic thesis and dissertation system, our news.psu.edu, NSF as well. So I have a PhD in information sciences and technology that I did my dissertation on evaluating electronic resources, and I was continually amazed at how complex it was to do anything sophisticated in terms of evaluation there. What I came away with from that was the recognition that this problem was so complex that people spent most of their time aggregating data and there wasn't much time for meaningful analysis. And that's not really what we're trying to get into in terms of the data gathering here, but it was a large, complex task every single time that I had in the back of my mind as we moved forward with this. And I wanted to make sure that whatever we did, we could bring data together from complex systems. We could do it repeatedly. And so that's really, the information came into other sources. We'd be able to update our information. Essentially, we update the RMD from different systems periodically. In some cases, it happens nightly. In others, we kick off jobs less frequently, maybe monthly. And the next thing we wanted to do is make sure that our open access, that we were able to power our open access workflow when that policy was put in place, so we could increase the footprint of openly accessible research at Penn State. And then we wanted to provide access to this information so that other colleges and campuses could leverage it for things like faculty profiles, department web pages. And we wanted an administrative dashboard so we could run and provide reports on common data requests without too much hassle. Again, this comes from some of my experience of aggregating data in previous times. There are no good ways to provide, really simple reports that folks were having. So first thing that we were going to focus on was the open access workflow for RMD. And for the purpose of open access, RMD is largely a citation index. We have over 200,000 citations for researchers currently at Penn State. There's also 160,000 presentations, 8,000 performances, 36,000 grants. A little over 1,000 news items, but a lot of that's used to populate the faculty profiles via the API, not completely relevant to open access workflow, but mentioning it in terms of looking at this larger dashboard. And so now we can see that we have this citation index. It's not a comprehensive list of publications, but we felt it was a good starting point. So we can start to find out which of these publications already has an open access copy. So we do this through integrating with Open Access Button, which is an aggregate database of many repositories, open access journals, authors, personal papers of open access articles. They don't use content from ResearchGate and academia.edu. But we query Open Access Button to see if there is an open access copy of a publication. If there is, we currently don't download that copy. We only record the link to the open access article. So as of this point, we have 67,043 open access URLs. It's about 33%, a little more, of our publications, and is a significant jump from where we were initially when we rolled this out last spring, which was about 19%. The point, though, is that we have a list of publications. We know which of those publications is openly accessible, and a couple things this allows us to do. One, we can, politely, ever so gently tap on the shoulders of our researchers with an email for publications that are openly accessible, and ask them to submit an open access copy to ScholarSphere, which is our institutional repository. Next, the faculty member can log into RMD and view these publications and either submit a URL or a PDF as an open access copy. And that's a very brief overview of how the researcher metadata database is helping us support that. Past year, you haven't heard many people talk about how great timing is. The timing of this presentation is pretty cool, though, because Penn State created that open access policy effectively January 1st, 2020. But our team just started sending out emails leveraging this system this week. So it's been an exciting week. We're reaching out to faculty that have published articles from July 1, 2020 and don't have an open access copy. We're doing this over the course of 5 days, where we have about 1,400 researchers that we're contacting. We've decided to send these emails in batches based largely on organization, so College of Engineering, College of Business, College of Liberal Arts, etc. And the intention was that if there's anything egregious that we need to stop the process and fix, and just logistically, if there's questions and support coming in, we want to be able to manage that in a timely manner. So spreading these emails out over the course of a week has allowed us this opportunity. And after yesterday, that was day 2. So today is day 3, but I don't have day 3 numbers. But after 2 days, we sent out just under 700 emails, and we've had 241 responses from faculty. So 35% response rate, where a response rate is where the faculty members either uploaded an OA copy or provided an OA copy or provided a link to an open OA copy, not just stop sending me emails. So it's pretty exciting, and I think it shows we have a lot of great potential here. Next, we wanted to provide access to that data. So for that, we created an API that provides that data in JSON format for people that are querying our database. So the first place we had is the Department of Food Science and the College of Ag. They're doing just that for their publications. And here's the department listing of those publications. And you can see if the article is openly accessible, they're providing a link to that content as well. So this is a great way to increase the exposure of the research at Penn State. So just a quick example there. I'm trying to hurry through here. Right, we've seen the repeatable, open access, and provide access to the data. So the next thing we wanted to do is the administrative dashboard. And so some of the questions that we're able to answer now without too much hassle from this administrative dashboard are: what journals do we publish in most frequently? What publishers do we most frequently publish with? How much of Penn State scholarship is openly accessible? We can analyze this by year. What faculty at Penn State are most prevalent authors of open access scholarship? How popular is the research of faculty that are publishing open access? How many people are we reaching out to in order to provide open access copies? How successful this effort is? And so, or just providing access to this data, and they can come up with, far more interesting questions perhaps as well.
Dan, this is your 2-minute warning.
All right, I will be quick. Thank you. So that's largely what we've been able to do with Researcher Metadata Database, RMD. Most recently, I didn't discuss much of the most recent integration, but fits into the theme there with integrating with other systems and reducing faculty burden. This fall, we integrated RMD with ORCID. So you can push your publications or your employment organizations to ORCID. And this is something we worked with the Office of the Senior Vice President for Research on, so that faculty that are applying for NSF grants are able to automate the creation of their NSF bio sketch a bit easier as new requirements came into effect as of October 5th, 2020. And so we're excited about automating and integrating this with a couple other systems, most notably ScholarSphere in the not too distant future, our institutional repository. And lastly, just want to thank my colleagues that have helped out throughout this project. Thank you.
Thank you so much, Dan. And now I'd like to invite all the presenters back onto the stage for a general Q&A session. And if you have any additional questions, please put them in the Q&A panel. And we'll start with scrolling down. Brian, you mentioned that you determined it was important and then added Scopus index publications and SciVal metrics. For what reason did you need to merge the two?
Yeah, certainly. Well, one of our early philosophies was to make a system that is beneficial to as many faculty as possible. And after some research, I mean, it's clear that there's some duplication of journal titles between Clarivate and Scopus, but there's also a lot of unique titles. So we have plenty of faculty who largely publish in journals that are indexed by Scopus. So we really thought it important to develop automation systems and get that high quality metadata and do a retrospective basically for those faculty. But now moving forward, and more recently, it's that the Scopus data is part of the Times Higher Education and the QS International rankings. So that's basically why it's probably the most importance at this point in time, and especially being able to use SciVal to generate reports for the different units to kind of see those baselines as to where they are at in terms of productivity and Scopus index journals. And we're doing the same thing for Clarivate, obviously, with insights for the U.S. News and World Report.
This is a ReCiter question. Paul, how is ReCiter similar or different to the Profiles RNS author disambiguation engine?
Good question. Profiles RNS is a system like Vivo for public-facing profiles, and they have a disambiguation service as part of that. So I don't know if you can run it independent of Profiles RNS. That's the first thing. So ReCiter is standalone, and you can use it. You can use it to feed a Tableau instance if you want. Has all these standalone services, and you can just create the services. So a couple other differentiators is that it makes better use of identity data. So I believe there's like 3 or 4 attribute inputs, like name, known PMIDs, institutional keywords. ReCiter tracks rejected publications, which is actually super useful, both so that you decide whether somebody wrote it, and then you don't have to, it helps in producing a better score. I'm not sure if Profiles does that or not. Anecdotally, the likelihood scores are more accurate, although we would probably need to do a study to prove that that's the case. But sometimes when I was testing with Profiles RNS, I noticed it would say a confidence score of like 99.99, and it wasn't quite the case. And then the final difference I can think of is that it uses weights for determining that it uses weights that were arrived at using a machine learning based process. So that's what allows us to have hopefully more accurate likelihood scores.
Thank you. Dan, do you rely mainly on APIs or homegrown methods for automating obtaining citations for your metadata database, or both?
APIs or homegrown
methods for obtaining citations?
I would say largely APIs, because even where there's some things that are coming in through faculty input, they're inputting into digital measures, and so that's a system that we're then querying via an API. So it's largely on APIs that we're getting most of that citation information from, whether it's that or even like static data that we're getting from Clarivate. That's more, I would say that's a script, but it's not really a homegrown data entry. It's the XML files that we're just parsing on an annual basis because we get that data in a chunk. Whereas like Pure, we do more frequently. Digital measures, we do nightly.
And here's the final question for scholars at FIU. Do you also incorporate ORCID IDs?
We do actually, and in fact, ORCID's essential in some ways, and Penn State already mentioned one of our needs, and that is to eventually allow faculty to develop easy biosketches and to populate the NSF grant. So And we're also going to be using ORCID as a suitcase, basically, to get data from scholars into Interfolio's product, Data 180. So we are using ORCID, and we will be promoting that extensively.
So here's the final question, and then we can move on to the networking portion. Dan, in my experience, publication data in DM is pretty messy. Example, people rarely enter a DOI. How much of your contribution does DM make to your database?
I mean, it's a significant portion of the data that we're getting in. The company hasn't given us any, like, resource help, if that's part of the question. So some things I didn't really get into in the sake of time, and we had to go through, and some other folks have mentioned that have similar systems that are doing things. I mean, we had at one point, you know, we had tens of thousands of duplicates that we had to kind of manually merge into single records. That was a lot of work. But part of also providing access to this content via an API was having a central location on campus, so that one, a bit of a service, not everybody has to learn some of the other APIs, and we can provide APIs and work with existing units to improve them how they need. And also, you know, some of these APIs go out of, they have major version upgrades on an annual basis. And so if the entire campus is using that API and there's a major version upgrade, that means the entire campus is having to worry about all of this, as opposed to one spot centrally just kind of taking care of it for everyone. So I may have gone a little too much in the weeds. Happy to answer any other questions, though, via email or whatever.
Well, I'd like to thank you all again, the panelists for their presentations, as well as attendees for their attention and engaging questions. I invite you all to choose a table in Remo and network for a bit. And please join us at the same time next week for a session dedicated to learning about leveraging relationships in research information management. Thank you again, and we'll return to the floor.
Thank you.
Thank you.